Welcome everyone. This house was built in the, well, we think in the 1870s. I'd like to show you around just a little bit. The house really contains three rectangles, and we're in one, which is the, well, this is a living room, and over this way is the kitchen, and Marion is there in the kitchen. And then over through this doorway is the third rectangle. We call this the post office room. There's a bedroom above this post office room, and there's a bedroom above this living room. So 2 bedrooms upstairs. The house is about 1,390 square feet. And there is a full height basement just under this third of the house that I'm standing in. Crawl spaces under the other 2. My wife and I bought this house in 2011. The house, when we bought it, was heated by an oil furnace in the basement under this part of the house. Duct work throughout, and I always had a sense that there was cold coming up from that basement. And we did, fairly early on, we had spray foam insulation put under these floors to try to redress that. But I think that one of the factors about the operation of the house is that all the duct work in these crawl spaces and under this part of the basement, all the duct work was uninsulated, and I think brought a lot of cold into the house. Apart from the relative efficiencies and costs of the oil itself, just having all these perforations in the envelope of the house with these uninsulated ducts, I think kept the house a lot cooler than it needed to be. In terms of the insulation, we have cellulose insulation that was here when we bought the place. The house exterior had been covered with vinyl siding, and there's about a 3/4 inch rigid foam insulation layer under that vinyl siding. And there are some of the exterior stud cavities that have fiberglass insulation in them, but not all. When we were living here, we relied significantly on a wood stove because of the cost of the heating oil. But we had tenants move into the house about 4 years ago, and I offered to pay for their heating oil. Partly, I was a little worried about risks of fire from not knowing how well they would do at operating the wood stove. But I found in those couple of years that they were here, 2.5 years, I found that the cost of the oil was just, it made the whole thing economically unviable for me. A lot of the winter months, I was paying as much for heating oil as I was receiving in rent, not counting all the taxes and other costs I had. Oftentimes we fill up a 250-gallon tank and have it go to empty in 1 month. So when I met Matt, who's on the call here at an electric car event 2 or 3 years ago, and started talking about heat pumps. And I had proposals drawn up, ended up deciding to get the heat pumps. I had 2 very good proposals, one from Halco and one from Snug Planet, and ended up going with the Snug Planet proposal. We have a Mitsubishi system on this side of the house, and let's take a look at this console unit. This is a 15,000 BTU. Well, they call it a floor unit. It's actually mounted to the wall about 4 inches above the floor. But it's distinguished from the wall units you usually see in that the air is coming out the top rather than out the bottom. And my wife wanted to have a console unit in this room and avoid having a unit up on the wall that would be very visible. So Mitsubishi at the time was the only company that offered the console unit. My understanding is that LG now has console units as well. But so on this side of the house, we have the Mitsubishi console here, and in the bedroom directly above us, we have a Mitsubishi wall unit, which we'll see. And outside, we have a 24,000 BTU outside unit. And so the runs are fairly short. It's from right outside this window into this unit, and then up the exterior wall to the upstairs unit. On this side, let's go into the next room. We call this the post office room because of this item of furniture over here. Something that was salvaged from, I don't know what post office, but it was in an old Grange building that we bought, and we brought it over here, and not quite sure what we're going to do with it, but it's giving its name to the room, sort of the second living room. At any rate, here's the LG wall unit, and the outside unit for that is pretty much right outside. You can see it through the window, I guess. And then directly above it, on the wall of the upstairs bedroom, is the wall unit there. So at this point, maybe we'll migrate upstairs and see those upstairs wall units, and then we can check out the outdoor condensers. So here's the LG wall unit, which I believe this is a 9,000 BTU output unit. This is the smaller of the two bedrooms. And they've got the house very, very nicely warm at the moment, and they're not having to work all the time at it. It's not too cold outside. Here's the Mitsubishi wall unit, and this is, I believe, a 12,000 K or 12K, 12,000 BTU wall unit. So one of the things for these upstairs bedrooms, they tend to get pretty warm in the summer. And when we were living here, we never used window air conditioners. We always found the noise to be problematic. We would open the windows and use a fan, but still, sometimes you get pretty hot. And so one of the really major advantages and motivations for us in getting the heat pumps was that they bring the ability to cool the place. I can tell you, during this past summer, we've had all three of our children and our four grandchildren have spent time here and have really appreciated that cooling ability. And I'll just note that my son-in-law, Jonathan, who's holding the camera at the moment, was one of the ones who was here. Jonathan, you have any comments on that?
Yeah, the kids definitely loved it, and I think it kept a pretty constant temperature throughout the summer. We spent some time here during the summer just visiting. Andy, you're getting a question from Jackie Dickinson. Do you hear them when they come on, or are they pretty silent?
Okay, so they're quite silent. They're much quieter than any type of air conditioner. This one It's actually not blowing at the moment, but frankly, I have to put my hand under it to know whether it's blowing or not, because when it's on a low fan setting, you really don't notice any noise from them. If you put them on a higher fan setting, you will hear the sound of the fan, but there's really no moving parts in here other than the fan. And Matt, maybe you can correct me. I'm sure there are probably valves in there that are opening and closing, but basically there's no mechanical noise that you hear from it. And the outdoor condenser, which we'll see in a minute, is very quiet. I was quite surprised. I think the first time I saw one of these was at an open house at Matt's place in Portland, and that was really one of the sort of turning points for me in hearing how quiet that outside unit was, and knowing that you could be socializing outside, or having the windows open. Probably wouldn't have windows open, but you even with them closed, you're just not going to hear a lot of noise from those units.
And just 2 cents to add as well. While I was here over the summer, I was doing a lot of work from home, and so having a lot of meetings, and sometimes the microphones pick up ambient or background noise, and I didn't experience any of that, and so there's no like humming in the background, or no difficulty for anyone in any of the meetings that I was with their ability to hear.
I'm going to turn the heat up so that the blower comes on.
So that's one of the things about these heat pumps, is that they do run sort of on a continuous basis. They keep it what they call low and slow. So they, they keep the air circulating in your house on a regular basis, which is good for ventilation. And it also keeps the air moving, so it keeps the whole house at a very similar temperature.
It's blowing now. It's on the second fan speed of I think they're either 4 or 5, and it's on not the slowest, but the next to the slowest. And I don't know whether you can hear anything on the other end. There's a very gentle breeze sound, I guess, coming from it now. First, we'll take a look at the outside units now. So here's the Mitsubishi. This is a little larger. It's got a little higher output from these two, because both units on this side are a little bit heavier duty than the units on the east side. Yeah, this is a 30,000 BTU condenser. The one on the other side of it is a 24,000. And it's since I turned the heat up in that upstairs bedroom, this is going pretty strongly. It's heating on both the upstairs and downstairs levels, but you can tell I'm standing right next to it, and I think you could probably hear me pretty well without much interference from the condenser. One of the first things they did was to level out some ground, put some gravel down, and then this is a pad that they brought in, and the stand allows for a better air circulation. The air is blowing outward from the house, so it's being kind of sucked in around to the back and coming through the unit. As it goes through, it gets, here in heating season, that air is getting cooled. The heat from this air, which is probably maybe 50 degrees out right now, that heat is being extracted and pumped into the house. And what we're getting blown out here is maybe, I don't know, 45 degrees or 40 degrees. It's you can tell it's a good bit cooler than the air that hasn't gone through this. But it still, amazes me that you can get effective house heating by extracting heat from relatively cold air, but it doesn't. I have not had any freezing of pipes. I guess, you know, formerly when the furnace was going down there, it would keep the right extra heat in the basement. But this past winter, that furnace was not here. There was no added heat, and I didn't have any pipe freezing last winter. So that would be something to factor in, I guess. Look at how well sealed your basement is and whether there are any openings bringing cold air in.
Does snow or ice ever affect the unit's operation?
You know, I have not had conditions where it has drifted up against the unit. I haven't seen any impact from snow just blowing into it or anything. I guess the only thing I would be concerned about would be if you had drifting conditions that were enough to, you know, to pile it up and block the fans here. I've not seen that happen here with the way our wind is here, but I think we do get drifting in central New York, and that would be something I would think about in your siding probably.
Right. That's also one of the reasons why the heat pump is up on that stand, is to make sure it's above the snow level. With the cold climate air source heat pumps, they do have a defrost cycle, and so they need to have space underneath them to drain out, even in the winter. And so that's one of the reasons why you see that. The recommendation from manufacturers and installers is to ensure that the air source heat pump is, you know, is free from snow blocking it in. So you want to make sure you have clear airflow to it. You know, in most parts of central New York, it means that, you know, once or twice a year, in a big snowstorm, you're going to need to maybe also dig out your air source heat pump as well as, you know, your driveway. It's certainly, if you're up in high in Oswego County where you get a, you know, 10 feet at a time, you may want to think about having this air source heat pump placed at a higher level.
If you know your house and you know you get large snow drifts on one part of the house all the time, well, let's not put something there.
So this is the LG condenser, 24,000 BTU, very similar pad. I'll just point out that in these lines, they call this a line set. Here you have the electrical feed, and this is a box where you can cut off power when it's being serviced. And then this white plastic channel is the line set, and it's got lines that are taking power to the two wall units. It's got a line that's taking refrigerant in and out, and it's got a third line that brings condensed water out. That line is, let's take a look at it over here. These are one for each of the wall units. So when it's operating in cooling mode, just like any air conditioner, you're going to get condensation on the cooling fins inside the house. That condensation drips out, comes down this tube, and just drips on the ground out here. Of course, we're not getting any of that this time of year because we're in heat mode, but in the summer, you get that dripping. And one of the things I'll note is that you get a dehumidification effect. Normally, if you run a dehumidifier in your house, you get a net increase of heat because it's burning power. And so you're actually heating up your house with the dehumidifier, which you don't want to do in hot, humid weather. These are cooling your house and dehumidifying. So, and there is both the Mitsubishi and the LG units have a mode that is a very slight cooling, low energy consumption, but it's dehumidifying. I think there's a little drip on your remote control that's indicating that's mode for dehumidifying the house.
Andrew, I'm wondering if you could offer any comparison between the floor console unit and the wall units in operation and comfort and such, and then maybe also any comparison you might want to offer between the two different brands. You kind of have a unique situation with two brands.
My observation is I kind of like the floor unit in heating season because it's putting out the warm air, lower down. Conversely, in the cooling season, I kind of like having the wall units putting out the cool air where it's going to come down onto you rather than stay down low in the room. In terms of, but really I'd say because of the way the fins work and the fans, they tend to direct it toward the middle of the room in both cases. So I wouldn't see a huge difference in the performance of console versus wall. As between the two brands, one thing I notice is that there's a minimum temperature that you can set it at. The LGs, you can set it as low as 60. Mitsubishi, you can set it as low as 61. And I'm not sure why they're each that way. When we're away, don't want to keep the house, somewhat warm to protect pipes and so forth. I'd like to keep it at 60. If I could do it at 55 or even 50, I would do that. So that's one thing I suppose there are probably technical reasons why they don't go lower than that. Other differences, the LG comes with a capability to have Wi-Fi connection that's built right into the LG, and so you can download an app. And I haven't bothered to do that here, but Matt and Halco and his team assisted me and fellow members of my church, and we put in a pair of heat pumps just recently at the Poplar Ridge Friends meeting in Poplar Ridge. And those, I have the app on my phone, and so I can remotely adjust it without, no matter where I am from the phone. So I believe Mitsubishi has the ability to do that, but you've got to get some extra hardware to do that with Mitsubishi.
Can an old single person deal with this system?
Let's go inside and look at the remote. Okay, so here's the remote. This is the Mitsubishi remote. Now, I'm going to take this sleeve off. There are all these buttons here, but in normal conditions, you don't need to mess with any of those buttons. You're just going to use either on or off and temperature up or down. So right now, I've got this one here in this console in the living room. I've got it set for 70. I'm going to push it a couple times. You hear it beep over on the unit, kind of acknowledging that it received the signal. And so now I've adjusted the temperature to 72. So really, I'd say you could go through the whole heating season and never have to use any but these three buttons. And I guess it's recommended that you not even use the on-off button. The recommendation is that you keep it running continuously and just adjust the temperature as needed. Now, there is a mode button, probably the next most important one, and you would push the mode button if you wanted to change it to dehumidify or to cool or to fan only. One thing that I was carefully instructed in the process is don't try to cool your downstairs while you're heating your upstairs off of the same condenser. the system doesn't like that, it will shut down. It's not going to break it, but it's going to say, you know, I can't do two things at once, and it'll stop working for a little while, and then you have to go back. I actually, my sister-in-law came and visited with our niece a few weeks ago, and the symbols on these remotes, there's a snowflake for cold, and there's a sun for heat. And my sister-in-law thought that if you wanted it to be cold, or if there was a snowflake, that meant that it was cold, and so you push the snowflake button to get heat. But it's the other way around. You push the snowflake button if you want it to be colder, if you want air conditioning. So that's an important thing to remember. I would say it's really not hard to operate. Just up or down temperature and know which mode you want it to be in. Okay, yeah, Marion's asking about any other maintenance on the unit. I have not had to do any maintenance of any sort on these. There is a procedure for changing the filters, and I've had them in place for 15 months now, and I probably should have changed the filters, but I haven't done that yet. I can't remember. Matt, can you weigh in on how often the filters need to be changed?
Actually, those units don't have changeable filters. They've got washable ones. So you just need to take them out periodically and, you know, hose them off in the sink or vacuum them off. They're a really fine mesh filter. Just pop them out, clean them, pop them back in, and away you go.
Okay, and am I remiss in having them in place for more than a year without cleaning them?
Yeah, if you go, I would go ahead and pop the front off of that unit on the floor. You'll probably find it's full of dust.
Okay.
So yeah, you should probably check them out.
Okay. I've learned something today, so yeah.
How much did each of the systems cost to buy?
I bought them as part of a single quote, and it came to a little over 16,000 for the whole system. And I think the rule of thumb that I had been told was that you can expect to pay roughly 5,000 per indoor head. This you know, either the console or the wall unit would be called a head. So, and these wall units or consoles, they range from, I think the smallest is about 7,000 BTUs up to, I think the largest are about 18,000 BTUs per hour. And there's not, the costs are not proportional. So two 7,000 BTU units are probably not any harder to install than two 15,000 BTU units. So it's a matter of kind of locating the units in different places in your house where you'll get you'll deliver the heating and cooling where you need it to be. But yeah, it is still a significant investment right up front. I guess, you know, my thinking is that if I'm saving, I would say ballpark, I might have been spending 3,000 a year on oil, and I may be spending an extra 1,000 and to replace that. So at that rate, I'd be saving 2,000 a year, and I'd pay for this system in about 8 years. Also, I'm adding cooling capability that I never had, and that is, I think, a significant enhancement of the quality of living, especially as we get, you know, sometimes hotter summers. Having that easy, inexpensive, efficient cooling is a big boost. And for me, part of the thinking also is that I think if we look at the trends in energy, there's more and more electrical energy being added to the grid, or more renewables with solar and wind. Those are electrical sources. And so I think you have a growing supply of electricity, essentially, and more competitive sourcing of electricity, whereas we've got finite supplies of oil and propane and natural gas. And so if I look ahead at the next 8 or 10 or 20 years, I'm anticipating that the fuel oil cost is likely to go up and up. I feel more comfortable betting on having my having an electrically based source of my heating and cooling, rather than being subject to the market fluctuations of fossil fuels. And of course, there is also sort of a good feeling that comes from knowing that I'm not burning fossil fuels here in to create my heating and cooling. Mary's asking about incentives, and there were some incentives that were built in. It would have been probably another, I'd say 20–25% higher cost had it not been for those incentives.
My house is made of brick. Would that be a problem for installation?
Nope, just takes longer.
Would they end up drilling through the brick?
You got to core drill the brick, yeah. It just takes longer, but it's not impossible.
Is your system not using ductwork?
The oil furnace used ductwork, and I have removed all the ducts. I tore out all the ducts from down there in the crawl space in the basement, and took them to pick and pull. So we now have, with these ductless units on the walls and here on all on the walls, all they're bringing in to the unit is the refrigerant liquid, which is bringing heat either in or out of the house. And then there's electricity, and then there's the condensate water going out. I think that's one of the pluses. If you're adding one of these units, you don't have to think about where's the duct going to run. If you already have ducts, you won't need them anymore unless you're leaving it there as a backup. But what I've witnessed both here and at our church, the guys come in and they drill a 3-inch hole in your wall, and everything comes in through that 3-inch hole. And then they seal around the hole, and that's the only perforation between that outside condenser and the inside head. And on the outside of the house, it's running through the that plastic housing. So there's not that much. There's not really carpentry to do. There's just a few screws to screw one of these units to the wall, and then that line set has to go through the wall. In this case, the line set is actually going down through the floor and then out. But the wall units, let's look at this wall unit here. There's a 3-inch hole in the wall behind this, and so all of the lines are going through that 3-inch hole and outside. And you can see there's there are no wires going to this, nothing on the wall inside. It's all going through that hole to the outside.
What Andrew has is called a ductless mini split system. There are cold climate air source heat pumps that work with ducted systems as well. And so instead of having these wall units, you would have a unit in your basement that would then connect to your ductwork. So there are options both for homes with ducts and for homes without ducts. And sometimes the ductwork does need to be modified in terms of making sure you've got the right size for the airflow. But again, every home is different, and this is where having an installer, talk to you about your home, come out and take a look, would give you a really good dialed in sense of what's possible.
I'd be happy to answer any individual questions, and if anyone would like to see the place in person, just be in touch with me. I'd be happy to show you around.